Welcome to the Real Python Podcast. This is episode 16. Are you using the Python library Pandas the right way? Do you wonder about getting better performance or how to optimize your data for analysis? And what does normalization mean? This week on the show, we have Hannah Stepanek to discuss her new book, Thinking in Pandas. The inspiration behind Hannah's book came out of her talk at PyCon US 2019. It was titled, Thinking Like a Panda, Everything You Need to Know to Use Pandas the Right Way. We discuss several core concepts covered in the book, and she shares techniques for getting more performance when working with data in Pandas. We also talk about a recent PyCon US online presentation about databases and migration. On a programming note, there was a little bit of noise on the recording this week. I did my best to edit it out, but be aware you may hear a little bit of noise coming from Hannah's connection. All right, let's get started. My name is Christopher Bailey, your host. The Real Python Podcast is a weekly conversation about using Python in the real world, interviews with experts in the community, and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hi, Hannah.
Hello.
Welcome to the podcast.
Thanks.
Tell me a little bit about working for New Relic. What do you do there?
I am on the security automation team.
Okay.
And so we basically write all the security automation tools, whatever those are.
Sure.
So basically, like right now, I'm working on kind of like fixing up an existing web application that was made by a previous employee. And I'm working with one other person. So our team is only 2 people.
Wow.
Very small.
That's cool, I guess, for communications.
Yeah, no, it's definitely different. Smallest team I've ever worked on. But yeah, so it's a Flask application, and then it has a Vue.js front end.
Okay. How much JavaScript stuff do you end up having to work with?
Well, right now we're just focused on the back end. So when I started a couple of months ago, they were actually transitioning their deploy from Amazon to New Relic's internal deploy system.
Okay, cool.
And in the process, we decided that for the next upcoming series of work, we didn't actually need a front end at all.
Yeah.
So we just kind of postponed that and decided to focus on the back end for the moment. We'll be redeploying the front end and doing some front end stuff probably at the end of the summer.
Nice. I wanted to talk to you about 2 different things. One is your book that just came out, Thinking in Pandas. And then if we have time, we'll talk a little bit about the PyCon 2020 online talk that you did about databases, SQL alchemy, and migration.
Yeah, totally.
So to start off to talk about Thinking in Pandas, the book just came out. Is that right?
Yeah, just this weekend. Very exciting.
Cool. I'll definitely include links to it, and it's on A-Press, right?
Yeah.
Okay. So who would be the intended reader for your book?
So it's mostly aimed at beginners, but I think there's something in it for advanced or intermediate users as well. Usually when you hear talk or read books about pandas, it doesn't focus so much on the performance.
Okay.
And my book really digs into the deep levels of performance.
Yeah.
It talks about, the data structures in Python and the data structures that Pandas is built on, and it's built on NumPy. So then it goes in and talks about, the performance of NumPy itself. And it, touches on also hardware performance as well.
Okay.
So I think that's probably the most interesting part of the book. It's less focused on all the different ways you can use it and all the different APIs, and more focused on how to use it correctly and get the best performance out of it.
Yeah. I definitely have seen that in previous workplace where I was working with some data scientists, and I could see sometimes, them just shrugging and saying, well, this is just going to be slow. And I would always kind of wonder in the back of my head, couldn't there be something that they could be doing to make this be a little more efficient and not just simply I'll just let it run overnight and that kind of stuff.
Yeah. Yeah, totally. It takes, and I think it really has to do with kind of the user base.
Okay.
I mean, a lot of the users that use Pandas are not, they don't necessarily have like a software developer background. So they don't necessarily get that,
Yeah.
Background of like data structures and performance and, how to use this and like, memory management, like all those details. So it really tries to like focus on that and kind of use that to explain why Pandas performs the way it does in certain circumstances.
Okay. So you mentioned it briefly there. If you were to dive in a little deeper and talk about like what is some of the underlying technology for Pandas?
Yeah. So it uses NumPy and it uses NumPy arrays underneath. And it in essence, like it uses C arrays.
Yeah.
And so C, they all expect it to be the same type. So that's like a huge performance kind of thing to note in itself is like if you have different types for your columns, that can be a huge performance slowdown in itself.
Yeah.
Which is something I talk about almost immediately. But then there's other performance benefits as well. Like there's like NumPy is built on vector registers, which allow you to do the same computation across multiple columns at once. So it's actually like a hardware speed up.
Okay.
So instead of like adding one to a single value at a time, you can add one to like a bunch of values at a time, like 4 values at a time inside your CPU. So that's also mentioned in there.
Yeah. Can I stop you there for a second? I haven't heard anybody talk about that before, and that sounds really kind of cool. So a vector, registers are talking about areas of memory, correct?
Yeah. Inside of your CPU, you load your memory into registers. And registers, are memory containers inside of your CPU.
Okay.
Where the computations are actually run and then like written back into a register. And after that happens, right, like then it takes that register value and eventually like writes it back out to memory.
Okay.
But yeah, so like that's something to keep in mind too. And NumPy is taking advantage of that. So like memory in general is something else to take advantage of. Is like you're working with huge data sets. And so you want to do you don't want to keep loading memory into your CPU. That's very expensive. And so you kind of want to grab like a chunk of memory and do a bunch of computations on it and then write it back out to memory and then load the next chunk. And that's kind of like where you might hear something along the lines of like cache, like taking advantage of the size of your cache. And that's what that's talking about. It's like talking about loading that memory into your cache, which is very close to your CPU, and then running computations on that and then writing it back out. So you're avoiding kind of this like iterating over your entire data frame.
Okay, sure.
Each computation.
And that's all happening with NumPy, which is written more at the C level than at the Python level.
Yeah, so that's all in NumPy and extensions to NumPy. So like NumExpression does that. But there's another library from the author of Pandas that's also trying. It's kind of like a branch where he's hoping will eventually be like the back end of Pandas.
Okay.
And so that's what he's trying to do in there is because Pandas wasn't initially written with that kind of like architecture in mind, but that's really where you get good performance speedups is if you can do that kind of like chunk based analysis.
Yeah. That makes sense to me, like in processing based on chunks versus, like you said, individual items, row by row or column by column.
Yeah. Yeah. And I mean, that's in essence, like what you'll often hear people talk about in Pandas when they say, like don't loop over your Pandas data frame. It's that same kind of concept of doing things like somewhat in parallel, right? Or like in chunks versus just like row by row or column by column.
Yeah, I guess we could move into that a little bit. In your 2019 PyCon talk, which I'll include links for, which is kind of your impetus for getting in and writing the book.
Yeah.
You talk about not using apply.
Yeah, definitely.
Can you explain kind of some of the thinking there?
Yeah, so apply is exactly what we were just talking about, where it's iterating over rows and columns. In my book, inside the apply chapter, I actually have an example snippet of code that is exactly the implementation of apply inside of Pandas, and it's just a loop.
Oh, wow.
Where it's calling like self.func or whatever, which is the function that you sent into apply. So it's literally looping over the rows or the columns and calling that function that you passed in.
Okay.
So, you could easily like implement that outside of apply by yourself too. There's really not much of a difference. But yeah, it's something I talk about a lot. It's something that a lot of like beginner Pandas users, it kind of makes sense to them, like if you're used to programming, you're probably used to like iterating over your data set using a loop, right? So it's very familiar, and you're probably thinking, in your mind, like, oh, I need to, run this function over every column or every row. So it's very familiar and easy,
Right.
but it's just not something you should do at all. It's very backwards thinking when working with Pandas. And in my book, I go into like some various examples, about like, here's a case where someone is using apply and here's what they should probably be doing instead. And there are a lot of different options for that.
Okay.
Like some of them are just, I talk about this in my presentation, my PyCon presentation. You can instead like use a built-in function right off the Pandas data frame. Or in my book, I give an example of using a NumPy array iteration instead.
Okay.
Or like a list comprehension, which is actually it's very fast. So like list comprehensions are sort of like doing a loop in C. They're optimized to that level in Python.
Okay.
So the interpreter, the interpreter optimizes the bytecode for a list comprehension to be more like a C loop.
Yeah, sure.
And so in that scenario, like a list comprehension may suit your needs perfectly and be super fast.
So I'm thinking about how that would be written, not to go too deep into a specific example, but typically the people that are working inside of Pandas, or most of their stuff will be inside of a data frame.
Yeah.
And so in a particular case, you want to process, let's say, a particular column that you would say, oh, I want to apply to that, right? Using the slower method. What you're saying here is you could take the data that's in that column, and instead of looping through the data frame and going through those values in each of the columns, is it sort of moving that data into a list comprehension and then putting the data back into the data frame?
Yeah, exactly.
Like kind of like you're kind of doing a sidestep.
Yeah, exactly. It's maybe, and I think there's a lot of those kind of what I, as a software developer, would say is a hack.
Okay.
It's not very pretty because, you have your data in this one format and then you're like, oh, but wait, I'm going to put it in this other format.
Sure.
And do something over here and then shove it back in. And it's a little weird, but at the same time, it can save you like many seconds.
Sure.
So it's definitely worth doing.
That sounds cool.
Yeah. But in general, I mean, the other, situation is like you have to use apply, right? Like you don't have a choice for whatever reason.
Yeah, I think you gave an example of like setting like almost like a case switch statement of like setting levels of values or whatever, like grades, or I think it was something like that.
Yeah. In certain cases where you literally like have no choice, you can write your like apply custom implementation in something like Python or something like NumPy, which basically converts it into C. And similar to like a list comprehension, though the apply case, you might not just be working over one column, right? You might have like several columns that you have to process.
Okay.
Stuff like that. You can also, I think in the case, in the example that I gave at PyCon, actually, there was a question afterwards and I felt really terrible because I could not hear the person at all. But later they pointed out that you can do like a query basically on your data table and replace it that way, which is totally valid. So rather than using apply, like in a case like switch statement like that,
okay,
you can actually use like a different method, which is totally fine too.
Yeah. So it sounds like you cover a variety of these techniques in your book. Do you go into C-level implementation with a couple different examples?
Yeah, definitely. For sure.
Yeah, because I could imagine that might be scary for some beginners initially.
Yeah, it's funny. I actually brought that up. So there was a Pandas discussion group at PyCon that year, and somebody was asking a question about that, and I brought that up.
Okay.
In that group, and they were very wary of when I mentioned C. They were like, "Oh my gosh, I have to know C," and it's like, no, no, you can write it in Python. It's fine. You don't have to know C. You just have to compile it. It's pretty simple. But yeah, just, that like switching of languages can be scary. And it's again, it's not a switching of a language, right? But it's even just like the, mention of it. It's like, ooh,
right.
That sounds terrifying. But it's not bad.
Yeah, one of the authors at Real Python, Anthony Shaw, he's just finishing up. Actually, his book is done on the C Python interpreter and the sort of the C Python internals.
Yeah.
It's one of those things where even myself, I'm like a little nervous to dive into that and, like look at like compiling
Yeah.
Python from, C Python. And, I've done a little bit of C programming because I was interested in iPhone sort of development stuff kind of early on before they moved into using Swift, which feels a little more like Python or JavaScript and those kinds of things. It's different, having to manage your own memory and think about those kinds of things. But it sounds like you're giving some decent examples in there to give people a leg up on, what it would look like to kind of get going.
Yeah. Yeah, totally.
So one of the key areas that you focus on is normalizing data. And so I kind of wanted to go into that. Like, what does normalizing your data mean?
Yeah. So, I mean, you get in a lot of kind of unorganized raw data.
Sure.
Like you might just, need to throw out some columns, or it might also include like standardizing columns or consolidating data from multiple sources. But at the end of the day, like your consideration should be like standardizing it into a format, like,
okay.
And then also like deciding what kind of format you want for your data frame. And as is like always mentioned in sort of like data analysis processes, like you want to save your data like at every stage in that process.
Okay.
So that you can always go back. So like you want the raw data, but you also want to save like the normalized data. And then, like as you go through the analysis, like you want to save each of those analyses too.
Do you have a preferred format that you like to save your stuff in as you work?
It really just depends on the data. I generally tend towards like multi-index data frames, but it really depends on, the data that you're working with and whether that makes sense. Like,
okay.
There are certainly cases where like having a multi-index didn't make a lot of sense.
And that would be compared to like leaving it flat.
Yes, exactly. I find a lot of people tend to work with flat data frames. Like at Intel, it was actually really helpful for us to have a multi-index data frame just with the data we were working with. We worked with a lot of group-based analysis and doing a lot of group bys. And when you when you find yourself doing a lot of group bys, it generally is easier if you have a multi-index data frame because it's already grouped. And you can also format it in a way such that like your group bys, you don't actually have to run a group by. You can just format it. And that's what I talk about, I think, like in my talk, but also in my book, is just being able to change the group by and eliminate it completely, because group bys are very slow and time consuming, and they're also not very simple and easy to look at and do in general.
Yeah. Okay. So to kind of give a general background on the concept of like having multiple indexes, can you think of an example?
Sure. Yeah. So the example I use in my talk is you have restaurant health inspection data, and you want to kind of like uniquely identify a restaurant.
Yeah. Okay.
And so the way that is done in there is by like the name of the restaurant and then the location of the restaurant. And we say that uniquely identifies a restaurant. And then from there, you can do like analysis on a per restaurant basis.
So that the top level index, for me to come up with just a generic term for it, would be a name. And in the case of many restaurants, they might have multiple locations.
Yes. Yeah.
And so a lot of restaurants may not, right? And so that ability, that flexibility there of having a second index below that, which has the actual location, which I think you were using kind of a modified sort of like a version of like a geolocation or whatever.
Yeah, exactly. Yeah.
But that makes sense. Like it could be like an address or something like that, or street or something like that.
Yeah, totally. Or like, I mean, another example is like if you have users, right? You have like a user table. You may want some like user data that may be helpful to keep in your data frame for whatever reason. But you also need to be able to uniquely identify a user, or even like a group of users, say.
Right.
Like at Intel, we were uniquely identifying a type of platform that we were testing. And so there are a lot of different platforms there, but it depended on like, I think 4 or 5 different criteria, like memory and CPU version, that sort of stuff.
Okay. And when you say platforms, you're talking about like it could be, individual computer
Yeah.
systems, or it could be mobile systems.
Yeah.
Or
Yeah.
okay, all right, yeah, because they go through so many generations with all the lakes, I guess.
Exactly. Yep.
Okay, cool.
Exactly.
So one of the other things you talked about, not only indexes, I don't know, say from one side, but maybe having indexes along kind of the top too, like kind of indexing the columns that way. I'm trying to think of an example
Hmm.
there.
Yeah, like multi-column indexes.
Okay. Yeah. So in that case, I think you were using maybe date as a initial one, and then sort of like scores or other things kind of underneath there. And
Yeah. So like the restaurants could have multiple scores associated with them. And you didn't just want to grab the latest score necessarily, because, so for example, like usually the way health inspections work
okay.
is the inspector goes to the restaurant, right? They take their notes or whatever, they give them a score, and then the restaurant has a chance to fix it. So you might end up, like, as a user of this data, you might end up in a lot of situations like going to a restaurant that may have like fixed all their violations and then kind of like let them slide back into being very unhealthy. And so like as a consumer of the data, you might not necessarily just want the, fixed score. Like you might want to know what the restaurant was willing to like let slide while they could.
Right. And then having the idea of like the time frames in between those visits and stuff too, I guess. Yeah.
Yeah, definitely. Yeah. My roommate is actually a chef, and so he said he was looking at that app a while back, and he was like, "Oh yeah, our restaurant is due for an inspection." And then like the next week he gets to work, and he's like, "Oh, yep, there's the inspector."
Welcome. Is that in Portland?
Yeah.
Okay.
Yeah, that was in Portland.
I was wondering because I heard you talk about it in the talk, and then I was trying to find that website that you mentioned, and I don't know if I was able to find the right address for it to find the data, but I was intrigued by it.
Yeah. So that was done by my ex-boyfriend, and he told me, I think it was like 5 or 6 months ago, he was like, "Oh, I'm taking it down. I can't afford the like $5 a month or whatever to keep it up." And I was like, "Oh no!" Like I use that all the time.
I referenced it.
I know. I'm like, "Oh, you're killing me." But yeah, it might not be up anymore.
Yeah.
But if a lot of people harass him, maybe he'll put it back up.
Well, I'm guessing it's public data, right? So it's just to be a matter of finding the source.
It is. It's totally public data. Yeah, and in fact, I think what is it? Yelp. I think Yelp.
Oh, okay.
Has inspection data now on certain cities. So like New York's is really easy to get a hold of, but like Oregon's health inspection data is a bit more difficult. It doesn't come in such a nice format.
Yeah, I was having a meetup with a local Colorado group, the High Springs, because it's Colorado Springs. They did a data.colorado.gov, and they were using a provider. They had a whole API and all this stuff. It was really slick way to get that public data, at least for Colorado, the government there. The local city one was more flat and less accessible, but yeah, it's really good information to kind of get a chance to play with. We recently had Kimberly Fessel on the podcast to talk about web scraping. And I think Yelp data would be one of those situations where it's not going to be something you can just throw beautiful soup at it. You're going to probably need to use something like Selenium to, act as a browser to grab those multiple requests and things, because it generates it that way. Okay.
Yeah. I think the job to pull down the data, it took a long time. I think initially it actually crashed their server.
Okay.
Because it was
requesting it?
Yeah, it was too many requests to it. Too close together. Yes. So,
okay.
there's
Gotta
that.
put some pauses in there.
Yeah. Lots of web requests. It's definitely nice when, like a data source makes it easy and accessible and posts it, in a nice like CSV or something that you can pull down. But
yeah, definitely.
Definitely not always the case, unfortunately.
Yeah. So one of the things I was thinking about to kind of go back to the normalizing topic is putting things into sort of NumPy type formats as opposed to just like, I don't know. I think the normal term for it is an object, a
Yeah.
pandas object or something, right?
Yeah, exactly. Yeah, so that's really where like you should be thinking about the types.
Okay.
Yeah, like the NumPy types. So you want to make sure that your types that you're using are C compatible. And a lot of times when you just rely on Pandas read CSV or whatever data loader you're using, it'll spit out the types in
Right.
just like objects, which are just general like Python object containers. So they could be anything, which are not C compatible and they're not performant and they're very large.
Okay.
So that's part of the normalization step, is to kind of decide like what types you want them to be, and probably along with that, like normalize your data such that it fits into that type. So like if you have any null values, for example, that's a very common problem. And it's actually something that they tried to address with Pandas 1.0. It's one of the major changes there, is like allowing, and like they built their own essentially like nan type or null type in Pandas 1.0, and they introduced, for example, like strings and Boolean arrays that can have nan values, or like that pandas null type in them, which is a huge win for performance.
Yeah, I could think so. Yeah, like normally it'd be nice to be able to not have it be like a full object just because there are some nan numbers or nan values in there when it could be just a boolean or or
Yeah,
a smaller integer or something.
yeah.
Okay.
And there are a lot of like, there can be some surprises with leaving them as like an object. Like if you have a column that you expect to be a number, but it's actually an object, and suddenly you have like an empty string in there, for example,
Yeah.
and you're adding numbers together, that can definitely result in some very interesting values.
Yeah, I can imagine. I remember somebody going through and let's say it's a health inspection thing like you were talking about before, and maybe one of the columns is zip code or something like that. And when you look at that data,
Yeah.
you could potentially, I could change this to an integer, but another way to look at it would be maybe to identify all the different ones that are used and sort of like classify them.
Yeah.
Yeah, which is another technique, right? To kind of simplify your data to make it a little more performant.
Yeah. Yeah. So there's a lot of considerations to be had there. I mean, there's also, you can always like take your metadata out entirely, like,
Okay.
and just have like a unique identifier. Pandas works a lot like databases. So if you're familiar with databases, and kind of like the techniques they use there, you can absolutely apply those
Yeah.
to your Pandas data frames as well.
Yeah. I think a lot of people, because it's maybe they're working in a Jupyter notebook and everything's so visual and, they may not, think about these potential ways to like a way a database engineer or somebody might think in that way. So it's kind of like giving them,
Yeah.
kind of a little bit of background on, oh, okay. And then, right away, like showing them differences in the memory footprint
Yeah.
um, could be a huge thing there.
Yeah.
Okay, cool. One of the things a couple things I wanted to talk about. One of them was you talk about advantages of a particular like loader over one or over another. Can you go into that a little bit?
The CSV loader is by far the most feature complete
Okay.
with the most options. So a lot of the Pandas loaders will let you do things like typecasting, and even in some cases, like specifying a multi-index data frame during load.
Okay. So you could do that all beforehand, right? As
Yeah,
you're importing everything
yeah,
in.
definitely. Or like eliminating rows or columns, or converting certain values to nans, right? Like if you have various strings that all are basically nan values, doing that sort of thing. There's some like date times, for example, converting those right away and specifying the format can speed up processing.
Okay.
There's a lot of different options, and unfortunately, they're not standardized across all the different loaders. So it really depends on the loader that you're using.
Oh, okay.
But I definitely go over pretty much all of the CSV loader options in my book pretty extensively, because there's just so many, and some of them are like super cool.
Okay. Lots of parameters to dive into
Lots
then.
of parameters. Yeah. So many.
Well, that's what's kind of funny is like, I think a lot of people might, skip past that. And I think that might be, just if you were thinking like what one step could you do to make your life easier? And that may be it.
Yeah, and a lot of them are like really lead to performance improvements too. Like if you just skip all of the like read CSV parameters and just load your raw data into pandas,
Uh,
like you might not even be able to load it into pandas, like for starters. Like you might just not have enough memory to do that. So, taking advantage of those can be a huge performance improvement.
yeah, that totally makes sense. This week, I want to shine a spotlight on another Real Python video course. It's called Finding the Perfect Python Code Editor. It's by Real Python instructor and previous podcast guest, Martin Broyce. Have you wanted to find the perfect Python development setup? Writing Python using idle or the Python REPL is great for simple things, but not ideal for larger programming projects. With this course, you'll get an overview of the most common Python coding environments to help you make an informed decision. And in the course, you'll learn about how to choose the Python editing environment that's right for you, how to perform common tasks like creating, running, and debugging code, and you'll dig deeper into optimizing your editing setup. I think it's a worthy investment of your time to learn about all the options for creating Python code. Find the right fit for your programming needs, whether it be a classic text editor to a fully integrated development environment. And like most of the video courses on Real Python, the course is broken down into easily consumable sections. Check out the video course. You can find a link in the show notes, or you can find it using the newly enhanced search tool on realpython.com. One thing that I thought was interesting in your talk, I worked in banking for a little while, and my wife's super into banking. She's like this total Excel queen. And she's like way, way, way into pivot tables and all that kind of stuff. And so when I was like just starting out and playing around in Excel and learned kind of how to use that, I was like, yay, it's so cool. And then when I got into pandas and said, oh, I can do pivot tables here. And you talk about that a little bit. And I thought it was kind of interesting that you have this take on it where, sure, use pivot tables early on at looking at your data and kind of understanding it. But then you say, well, it's really not going to be that useful to use them later. And I sort of wanted to go into that a little bit.
Mm-hmm.
Why do you feel that way?
Yeah, so I think that really comes back to normalizing your data frame.
Okay.
And in your data initially. It's something like pivot tables are really great for like reorienting your data frame. Like if it's just, completely in the wrong orientation and format, which a lot of times it can be. It's really powerful for that because it just lets you specify all that stuff right there and completely, destroy it and take and redo it. But if you're doing that a lot, like throughout your code and your analysis,
okay,
that to me says a couple things. Like one, your data probably isn't in the right format to begin with. And also you're using a lot of memory by doing that. So like when you do that pivot table, you're basically like copying everything and rebuilding it. And so you're working generally with like very large data sets here. And so if you find yourself like copying and rebuilding memory all the time, that can be a huge performance hit.
Yeah, that makes sense. Yeah, I think of like the reasons that people typically want to move that stuff around is mostly for presentation. Like, I'm going to chart or graph this stuff out and, or, doing some form of aggregation in that way.
Yeah.
But yeah, okay, that makes sense to me. And also the multi-indexes kind of help you with that too, right?
Yeah. I mean, I can't emphasize enough just like taking the time to plan out like how to orient your data frame.
Yeah.
Like I can't say how many times I've gone to like skipped ahead to like do the data analysis step and then been like,
yeah,
wait a second, like this is not the right orientation for this. Like and going back and redoing it. So I mean it's really important to like do your research and you're just like think about it. Just like take a time and consider all the analysis that you're going to do on it first and like all the, the different types that you expect and the different columns that you need and all of that stuff and really like take the time to plan it out because it can make your data analysis like so much easier.
Yeah, that makes sense. Yeah. What are considerations that you have for improving performance? And I think you mentioned that doing some of the Pandas operations with other Python libraries.
Yeah.
So what are considerations there?
I mean, it really depends on the use case. So I personally, because of my like software developer, I don't know, brain, I'm like, no, I don't want to jump out of a Pandas data frame unless I really have to.
Right.
Because for me, it kind of goes back to that like hacky, sort of like I'm going to use this object and I'm going to make it work. And this is what I'm supposed to be using. But if it really just depends on the use case. If it ends up being more performant, like it's definitely simple to use, built-in Python functions that are available to you, like built-in Python features. If it makes it easier, then by all means, like in more performant, then definitely do it.
Okay.
It really depends on the scenario though. Like I can't necessarily give you too much without like, delving into like a particular use case and example.
That makes sense.
But yeah, really just depends.
Yeah. Okay. Was there a particular topic that you were more eager to share than others when creating this book?
I guess like the part that I enjoyed talking about and writing about the most was just the performance of it.
Okay.
Just like talking, really like digging in. I think this was really fun for me too, just like in researching, because I ended up doing a lot of like breakpoints and jumping into the Pandas implementation and walking through the Pandas implementation and then like hitting C and then walking into C, like all of that stuff. It was really fun for me and really interesting. And just like talking about all that stuff and kind of like pulling in like all of my kind of like computer sciencey background knowledge, as well as my knowledge of like the Python interpreter and all of that stuff, and just like connecting all the dots for me, I think was really fun. And I think it's really valuable to do.
Yeah.
Like we have all of this like knowledge available to us all over the place, but sometimes it's like hard to connect the dots and, go in and like truly understand and explain what's going on under there. So
when you talk about that makes me think about, okay, what type of tools do you use to accomplish that?
So mainly I just use like PDB and then like GDB for C. All the command line tools.
All right.
Yeah. And then there's like some like C profile too for Python if I'm looking at like timing and stuff like that.
Okay. So profiler. And so as you were doing that, were there some good resources that you can mention that people could look at if they were interested in?
Yeah.
I mean, obviously your book is going to be a good resource to kind of get people going on this sort of stuff, but if they want to do that deeper delving and stuff.
Yeah. Gosh, it's been so long. Mostly just Google, honestly.
Okay.
Like if you just Google like PDB and GDB and stuff like that, like C profile, really useful.
Yeah. Are there good resources you can think of that you used while learning Pandas itself? Not the deeper levels, but just kind of, learning best practices.
I attended a lot of Pandas talks, but also like I think the documentation now, like when I started using Pandas, the documentation was not super helpful.
Okay.
But nowadays it's actually like very, very good.
Okay.
They even have a section in there specifically like on performance.
Okay, cool.
Which is really great. And I'd highly recommend reading it. Like I do talk a lot about the stuff mentioned in that section in my book and like go into more detail, but just like even as a beginner Pandas user, like if that had been there, I totally would have benefited from that.
Yeah.
Like it's kind of seen as like an advanced user sort of thing, but I think it's really valuable like to read just like as a beginner too, because it kind of like puts you in the mindset of working with Pandas correctly.
Do you feel the changes around 1.0 as far as the documentation?
I think, yeah, the documentation has definitely been improved since Pandas 1.0, but I think a lot of these changes like happened prior to that, and they've just been even like improved more in Pandas 1.0.
Yeah, it's kind of funny. Like you said, I if I get stuck on a Python particular problem, the first thing is Google or DuckDuckGo or some of the kind of thing to kind of dive in. I'll use DuckDuckGo sometimes just because I don't want it to stick me in my filter bubble, if you will, if that makes sense. And so I want a different answer potentially.
No, it's totally true. Yeah.
And so that's kind of nice sometimes to use a different tool to kind of do that research.
Yeah.
But lately, if I'm looking at, the true implementation, I've been going to the Python docs themselves and looking at that. Often there'll be actual, examples and explanations and stuff that sometimes will go deeper than just like, something that would be, on a mesh board or what have you. So
Yeah, totally. Yeah. I mean, there's like a fair number of like, as embarrassed as I am to say, perhaps, like Stack Overflow answers to like Pandas questions. And like, while you definitely have to like filter Stack Overflow, for like the actually correct answer, because a lot of times like the selected answer is not necessarily, the best one,
right.
whatever. But in particular with like Pandas and like particular performance solutions, like they seem to be pretty like innovative and interesting to read.
Okay.
Like a lot of them will talk about, kind of like avoiding like certain methods just the same way that I do in my book, or like suggesting alternatives.
Right.
The kind of those like alternative, perhaps like somewhat hacky, but also like super performance solutions.
Yeah. So I wanted to delve a little bit into the PyCon talk that you did recently for 2020 PyCon Online.
Sure. Yeah.
Well, I guess let me just start off. Let me have you just tell me a little bit about the talk.
Yeah. So it talks about like an ORM, which is SQL Alchemy, and then doing database migrations using Alembic. And I would say like those are probably like the most common libraries to use like outside of like Django.
Maybe we could talk briefly about like what an ORM is and maybe like kind of what it's doing.
Yeah. So an ORM stands for Object Relational Mapper. So the idea is you're working with a relational database and you have your database tables represented as like classes or objects in Python. And it's a really nice, like easy, simple kind of like implementation. And it also makes sure that your database tables or like objects as they are in Python exactly match what's in your database itself, which is also very good and nice.
So it's making that transition for you between the object-based world of Python and the tables and other stuff of a relational database.
Yeah. So it's like avoiding that whole having to write like SQL queries, like as strings, like in your code.
Yeah.
You can use nice little functions like filter or query or whatever. And it makes it a lot nicer to read and talk to your database. And it avoids those kind of like long, arduous strings that are very database specific.
Yeah, coming from a SQL world, I've created those. Yeah, and it can be kind of clunky. SQL has a very, very structured way of thinking about it.
Yeah, it lets you, like catch those kind of like, I, accidentally put the wrong column name down, or like I'm writing this data and that's not allowed. Like this field can't be null, but
sure,
stuff like that. It's
yeah,
nice syntax.
Why would you pick one ORM over another? What are there specific features and things that you would look at?
Yeah, so there are a lot of considerations that would go into that for me. Like not only like what databases are you talking to or do you plan to talk to, but also like, is it a nice, syntax to write and use? Does it enable you to define in your database all the things that you would like to define and optimize all the things that you would like to optimize? So like, what are you going to be taking advantage of, like database specific features? Like if you're using Postgres, are you going to make Postgres specific indexes? And does your ORM allow you to do that? Or is it just like a high level sort of thing? Is it compatible with the like web framework? If you're using a web application, is it compatible with the web framework? Also, like how would you define a transaction and the scope of a transaction? And how would you like initialize a database connection and request? Like, does it have built-in connection pooling, right? So you don't have to like reestablish your connection to your database all the time. Like all of those are very, very important considerations. Like also, I recently came across this personally at New Relic. fun fact. Also, like, are you going to be using these database table definitions just inside of a web application, or are you also going to be needing to like share them with another tool, which is like outside of a web application as well? So like all of those are very important considerations.
Okay. Out of that group of different ones that are out there, you picked SQL Alchemy in this particular case.
Yeah, it's seen as kind of like it has a very generic syntax, which is great if you want to maintain a database agnostic, but it also has capabilities of like issuing database specific kind of like features, which is really nice if you need to make, like a Postgres specific sort of like index optimization or something like that.
Cool.
So it's seen by the community as kind of like a nice middle ground in all of those areas.
Yeah, no, that's good.
If that makes sense. Like it's generic, but it also lets you do database specific things.
Yeah. And then you delve into, in the talk, talking about migration.
Yeah.
In your particular case, you pick up the tool Alembic.
Yeah,
if I'm
Alembic.
pronouncing that right. I think it's like, it's kind of funny because I think both those, like SQL Alchemy and Alembic, like they're alchemy and wizards and stuff. And I think Alembic is like a tool that's used for, doing alchemy or something.
Alchemy, yeah. Yeah.
Anyway, okay.
Yeah.
Sorry, nerding out there.
Yeah.
So in the migration tool, what's that doing for you? What is Alembic doing for you?
Yeah, so it's kind of a scary thing
okay.
to run a raw SQL query on a production database.
When you say that, do you mean the types of queries that are creating tables, creating columns, removing rows? Okay.
Yeah. Yeah. So moving data, creating a new database table, etc.
Okay.
It's really, and again, if you find yourself, if you're doing that, but you also have, something like SQL Alchemy where you have your table definitions defined in your code, you might again run the risk that your database table defined in your code does not match your database table that you just created in production. Right. So there again, like it would be nice to reuse your table definitions and make sure those things match. But on top of that, like it's nice to be able to track what changes you made to your database.
Yeah.
And also be able to, God forbid, if something goes horribly awry, revert that change.
Yeah.
And also if you're working on, as most of us do, like a project with multiple team members, it's nice to just be like, hey, I wrote this migration script, like just run it and it'll
build you one.
Yeah, you'll be where I am in the database version history.
Yeah. Okay.
And it's really nice to be able to like test it, right? And also get review, right? We as like humans and developers, no matter how good we think we are all prone to making stupid mistakes. In migrations, is one of the many areas in which we can make those mistakes, right? So like if you have script, you can get your teammate to review it and make sure that you didn't do something stupid.
Sure. Yeah, that's cool. You made some comparisons in your talk to it being a little bit like Git, in the sense that the migrations can be labeled and have a head that you can kind of choose where you're at within the levels of migration, if you will.
Yeah, exactly. I mean, the idea is that you should be able to walk up to the latest revision and walk back to the original version that was released, and it should work regardless.
Cool.
And often, unfortunately, like the reality in the real world, I find is that that's not always true. It's especially when migrating data, so like making data changes to production, like some of those you may, for example, like have to, and I talk about this in my talk, like default some or migrate some existing data to a particular value, right? And like once you've done that, it's very hard to undo that without tracking exactly which tables you changed, right? Or like which columns you changed, because your production data is going to continue on. Like you're going to have new rows in that database, right? And so it's hard to sometimes revert that change. So the revert in that situation like may just be like nothing, and that's okay. But still, and it's also hard to it can be somewhat frustrating, I think, for developers to do migrations. Like oftentimes as developers, we're not always like super into like database stuff, as much as like a database engineer would be, right?
Hey, it goes back to our earlier talk, huh?
Yeah, right. So like we get a little annoyed when we find that in order to do things correctly, we end up having to do like 3 or 4 migrations in a row in order to achieve some goal.
Yeah.
And I to that, I would say it's just like making a change in your code base. Like you should treat it with the same amount of scrutiny and the same amount of carefulness that you do when making a feature change. Like a feature may consist of many PRs in a row. And that's kind of the same as a database migration. And so it's very important if you want to do things right and you want to truly maintain the backwards compatibility
Right.
and be able to revert your database like back to its initial state, it's very important that you do things in order and you do things correctly and you take the time, right? As many migrations as it takes to do that and accomplish that.
So better in smaller steps,
yes,
potentially. Okay.
Yeah. And I think like in my talk, I just go over like one particular change, basically, like from a high level, right? Like one feature addition, but it ends up being like several database migrations.
Yeah, it's like a cascade.
Yeah.
That makes me think about I recently had Anthony Shaw, I mentioned him earlier about the C Python internals book, but he came on to talk about testing. And we talked a little bit about continuous integration and, having a setup where as you commit, do a git commit, that it will then run your tests against it.
Mm-hmm.
As opposed to, we were joking, what can be common if you're developing by yourself, maybe you're, just in that state of working from home and all right, done for the day, commit, and how that might be fairly disastrous for all the different changes you might have made.
Yeah.
So it might be good to make the smaller changes, have it test. And I was thinking about that with the migrations. Is there a sort of a testing kind of layer to that you have to think about?
I mean, I think with migrations, like the idea is that you can test them, and usually the test isn't necessarily like a CI test.
Okay.
Although certainly, like when and where you make that change to your database models, like that should absolutely be tested. So those classes that represent your database tables in Python, like those should absolutely be tested. And so generally when you're making a database migration, unless it's just modifying data inside of production, you're likely making a change to one of your models. And that will absolutely like have unit tests associated with it and run in your CI. But as far as like actually testing the migration, typically like the flow would be, like you test it locally, run the migration, then you downgrade the migration. You make sure that everything looks good on both sides of that. The reviewer will typically do the same thing on their end, right?
Okay.
And at that stage, at least, like that 2 of you have done it and it looks fine, and then you release it into like a staging environment at some point where you can again run that migration on staging, which generally looks like almost identical to production, though it might not have like exactly the same amount of data as production has. And then like you have that guarantee there as well. Like you have that test. So then when you run it on production, you've tested it at several different layers. So you're pretty confident that it's going to work at that point.
Cool. Do you do lots of talks?
I mean, I've done a couple at PyCon. I did another one, locally in Portland. I've done some talks at meetups. Unfortunately, there aren't many meetups going right now.
Yeah.
Which I was totally...
Ours was virtual last night.
Right. Yeah, I've attended some virtual meetups. The Python meetup that I usually attend here in Portland and often give talks at is not running right now. It's actually hosted at New Relic, where I work now in our office. But hopefully at some point.
Can I ask you a question on that?
Yeah, go for it.
Is that how you made the connections with some of the people there?
Yeah, in a manner of speaking. Like actually, like how I got this particular job is like actually like through my roommate, through a friend who works at New Relic.
Okay.
I also attend like board game nights at New Relic because I have some friends that work there. Yeah. So a lot of people like thought actually did work at New Relic like long before I actually started working there. Pretty much, yeah. Like, I know you guys have a cool office. You have fun events. I'm on board.
So it wasn't a big change when you just walked in the door. That's cool. Yeah. What kind of games do you play? Sorry, take a tangent. I'm into board games myself. So,
My favorite, some of my favorite board games are Captain Sonar,
oh gosh, I don't know that one.
which is like Battleship, but it's like live Battleship. So you have a team of like 3 to 4 people,
Okay.
and you're just moving your ship like around the board like Battleship, and you're trying to hit the other team's ship. But you have different responsibilities, and it's live, so like everyone's screaming at everyone
Yeah.
because the captain is like calling out north and south and east and stuff like that. The other captain is doing the same thing, and got like somebody tracking their location and stuff. It's like total chaos. Like, it's definitely not something that I would recommend playing like after a very long, intense day at work, for sure.
Sounds fun.
Because you don't want to be brain dead while playing that game.
Okay, cool. Yeah, I was asked to bring in some games for my last job I had when I was working in Hawaii, and I brought in this French game called Dixit. I don't know if you've ever seen that
Oh
one.
yeah, I have.
That one's kind of fun because it really makes you think about like how other people on your team kind of think,
Mhm.
and you can kind of like learn about the different processes just by the ways they kind of combine stuff together. And I don't know, it's a fun one.
Yeah.
Cool. Is there another one that is common that you
Oh,
play?
so many games. So many. Let's see. Splendor is really fun. It's like a deck building game. Dominion is also a deck building game that I really enjoy.
Yeah, I have that one.
Yeah.
Yeah.
Yeah, there's like Secret Hitler too. That's a game that they play all the time at New Relic.
Awesome. Well, I have these questions that are sort of weekly questions for the podcast.
Sure.
And the first one is, what are you excited about in the world of Python currently? And that can be, hardware, a package, could be an editor.
Yeah, so I guess like personally, I'm really excited about async. It's been taking off a lot, and unfortunately, I have never written an async Python app
Okay.
date, but I would love to. My async experience is mainly in JavaScript at this point, but I think it's really converged a lot, and it's something that a lot of other languages are picking up on and implementing as well.
Yeah.
So it's a big push, like just within the software community anyway. But in particular in Python, it's been worked on significantly in Python 3
Yeah.
and standardized and fleshed out, and it's becoming a lot more user friendly, which is great to see.
Yeah. Yeah. I had Wukas Longa on episode 7, and he works for a company called EdgeDB, a database company, after leaving Facebook and so forth. And he was talking about, we did a whole thing about async and music. He was creating this live sequencer, which is really kind of a cool example. And
Yeah.
he created this whole set of tutorials for EdgeDB that kind of dive into async, and I would definitely suggest them to you. They're pretty cool.
Awesome. Yeah.
Yeah. I guess this might be related to that. What do you want to learn next in Python?
Yeah, I mean, definitely like async is on my list of things. Something I learned like actually in the last like 3 weeks or so is Redis queue.
Okay.
So yeah, like I started using RQ, and that I'm sure I'll have some more experience in that pretty soon at work.
So I'm familiar somewhat with Redis. What's Redis Q?
So Redis queue, it's on the same lines as Celery, but it's a higher level implementation.
Okay.
So it doesn't like give you all of the, I guess, like low level features that Celery does, but it's a nice kind of like high level, like here's a queue, like here's a scheduler, or like I'm gonna like add a task and create a task and add it to the queue sort of thing, and like it gets its results back and stuff, and it handles kind of like all of that like low level stuff that you might have to specify in Celery for you, which is nice, like especially right now because I'm on a team of 2 developers and we don't really want to deal with all of that overhead.
Be nice to automate some of this chronological stuff.
Yes.
Okay.
Yeah, exactly.
Cool.
Yeah.
Nice. And this is a question that kind of goes back a few episodes ago, and I'm sorry to spring it on you, but I was wondering if you might have an idea on it. I had a question from a listener, and he was wanting to learn more by reading code. And I don't know if you've ever done that. I mean, it sounds like you have done that to a certain level with Pandas, but have you ever studied code by going in and reading a library? Is that a way that you in the past?
Oh, yeah, absolutely. I actually did that a lot with Redis queue because the documentation isn't super fleshed out.
Okay.
Yeah, definitely. Like if I need to, like if the documentation isn't cutting it for me, I will absolutely go on GitHub and look at the implementation.
Cool.
In fact, sometimes I find it's faster. Like if help, for example, or like isn't giving me anything back for a particular function that I'm using, like I will absolutely look at the GitHub implementation of the class or the function that I'm trying to use and read it. Yeah. And along with that too, like browsing GitHub for like existing projects is like super helpful. Like if you have a bunch of architecture questions or you're like, I don't know how to implement like a queue at all. Like I don't even know like where I would start, right? Just like browsing examples on GitHub of projects that do that is super valuable.
Yeah. Do you have a particular library that you think is particularly written well?
Oh, let's see. I mean, I think I'm trying to think. I like Redis Q for the most part, but there are some things I don't like about it.
Okay.
But it is pretty simple. What was the other one I was looking at the other day? It was pretty nice. Oh, it was actually it was an extension.
Okay.
Yeah, like some of the Flask extensions are pretty nicely written. I can't think of what the particular extension was I was looking at the top of my head, but yeah, some of those are like really simple and elegant, and that's nice to see. Like it's nice when you can go look at something that seems really complicated, and you only see like a couple files.
Yeah.
Right. Like that's always a good sign.
Yeah, no, I agree with that too. Just even looking at the repository before you get to the code level and just like the names, if it's named well.
Yeah, totally.
Oh, cool. Well, I really want to thank you for coming on the podcast and talking to me and sharing all your knowledge.
Yeah, definitely. Thanks for having me.
All right. I want to thank Hannah Stepanek for coming on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure you subscribe to the podcast in your favorite player. And if you like the show, leave us a 5-star rating and a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Paley, and I look forward to talking to you soon.